Many of you guys will love this question, especially if this is the first question on your university entrance exam. You should be really happy. Check this out. For this part of the question, we will show that between two consecutive roots of f of x is equal to 0, g of x is equal to 0 also has a root. And this time we have the condition that the derivative of f is equal to negative g of x. And technically, it's for all x in R, but they didn't mention that in the question. They should, in my opinion, but it's here. And of course, I know what you're thinking. Cosine and sine. True that, because the derivative of cosine is negative sine. This right here is pretty cool though. This is called the interlacing zero property. But anyways though, let's see. We want the proof. First, though, we need to have two consecutive roots for the function f of x is equal to 0. And I will just say, let them be a and b. And I will say a is a smaller root, so let a be less than b. Since they are the root, they have the property that when you plug them in, you get 0. Now, how can we make it consecutive? When we have a and b, the function will be 0, but anything between, we don't get 0 anymore. So I will have to say, and f of x is not equal to 0 for all x on a to b interval. Like this. Truth to be told, you don't need this part for this part of the question. But I think it's just that they write this down so that they can have like the same kind of statement for the second part of the question. So I will say this is not needed, but I will keep it here. Right, I'll keep it here. You'll see we don't need to use this. Anyways, f of a is equal to f of b. Like this, right? They have the same y value. What can we say? This time, unlike the video that I made previously, where we only had continuity, this time we have differentiability for f. So we get to use the mean value theorem, or maybe in particular, the Rolle's theorem. And that's exactly what we have to do, especially you have this very nice derivative. But before you use the Rolle's theorem or mean value theorem, please just mention the following. I'll just say, since f is dable on R, that implies, first we mentioned that f is continuous on the closed interval AB, and of course it has to be dable on the open interval AB. And in fact, if f is dable on R, let me just mention that real quick. I don't know if you really have to mention f is continuous on this, but let me just be like following the theorem statement. So let me mention that. All right, because we want to end up with 0, quote the Rolle's theorem. So by the Rolle's theorem, with an E. Thank you guys so much for pointing that out last time. By Rolle's theorem, we know that there exists some C on this open interval such that the derivative of f at C is equal to 0. And we are pretty much done. Why? What's f prime of C? The derivative of f is negative g of x. So this right here implies negative g of c is equal to 0. Notice that there's no prime anymore because the derivative f is negative g of x. And of course the negative doesn't bother us. And that's just i.e. that is g of c is equal to 0. And we're done. Because we have shown that there is a c on this interval such that that will make this 0. So c is also a root for this equation, and then we are done. Now, let's take a look at part 2. Now for this, we will show that between two consecutive roots of g of x is equal to 0, f of x is equal to 0 has a root. And the condition that we need is the derivative of x times g of x is equal to x times f of x. This time, unfortunately, sine, cosine don't work anymore. But anyways, let's see how we can do this. Same start, PF, let A is less than B be the roots of that, so such that G of A is equal to G of B is equal to 0. And this time, you will see that we really have to mention that A and B are consecutive roots. So we write down what we did earlier, and our function G of X is not equal to 0 for all X on this interval. Now, can we use the Rolle's theorem? Yes. In fact, I'm not going to apply the Rolle's theorem to G, because notice that this time we have the derivative of X times G of X. It would be easier if you call that to be a new function and you go from there. So I will do just that. So let H of X be equal to X times G of X. Now, in fact, H will also have A and B as the root. So I'll just have to mention that a few things. Note 1, I'll say. Yeah, note 1. Okay. H of A is equal to H of B is equal to 0. How come? Because when you're plugging A into this is just A times G of A. And thanks to this is 0. And likewise, same thing. This is B times G of B. So H is going to be the same thing too. Now, again, before you use the Rolle's theorem, mention the things that I told you earlier. So note 2. H is continuous on AB because H also has to be kind of differentiable everywhere, right? X times that. And deable on the open interval AB. All right, so that's all we need. Now, do the same thing by the Rolle's theorem. There exists some C on the open interval AB such that I'm applying the Rolle's theorem to H. So I'll write down H of 0, well, H prime of such that the derivative of H at C is equal to 0. And of course, that implies I'm just going to look back here. This is my function H. So take the derivative H prime is the same as this. So I just have to plug in C into here and here, which implies C times f of C is equal to 0. Now we are almost done, because if we can get f of C is equal to 0, then we are done. However, there's a C right there though. Can C be equal to 0? It better not, because if it's equal to 0, I don't know how to continue. So C better not be equal to 0. But how do we make sure that it's not equal to 0 though? Well, notice we haven't actually taken the derivative of H, right? Legitimately by using the product rule. So why don't we try that? So here's the start, I'll say, because H of X is equal to X times G of X, which if you use the product rule, H prime of X is X times G prime of X plus G of X. And then if I plug in C into this equation, H prime of C is equal to C times G prime of C plus G of C. And then by what we have right here, it has to be equal to 0. Okay, now I'm going to move this to the other side. So we are looking at C times G prime of C is equal to negative G of C. Alright, so far so good. Now what though? Well, notice that there's one condition that we haven't used yet, right? And that is this one right here. Remember we mentioned that G of X is not equal to 0 for all X on the interval AB. Since C is on this interval, so G of C cannot be equal to 0. So right here, I'll just say this cannot be equal to 0, and I'll come back here, I'll just call this star star. So by star star. Now, if this star is non-zero and we have C times this, could C be 0 right here? No, because otherwise 0 times whatever that number is, we get 0, right? So this implies that C cannot be 0. Alright? So C cannot be 0 by the blue star. Okay? The whole thing, right? The whole thing. This is the blue star. Alright, now this right here implies that f of C has to be equal to 0. Well, ladies and gentlemen, we are done. So lovely, isn't it?